We're at our number 8, our framing stage. We're at our Brookside house, and we've got it framed in now. So I'll show you what we got going on the outside. This outside has a little different siding on it. It's got lap siding on a couple sides, comparable to the just a standard woodsman siding that's up and down. And we're going to have a stone fireplace on this one, so it's ready to be stoned. And we'll going to stucco the front, so we got some wind wrap on the front, and then we'll go inside here. On the framing, I'm on the interior, and this is a great room. It's got a vault, and at the very top of the vault is a 16-inch beam that the rafters hook onto. Now, the ceiling rafters are a couple different sizes. Here in the kitchen we have a flat ceiling, and those rafters are only basically 2x6s, and 2x6s means that they're 6 inches tall, and so those there are just 6 inches. Our great room's got a vault, so it takes the little bigger material. That is 10 inches. So the vaults are usually bigger. And if you can tell, up through the ceiling, they got ceiling rafters are up there, way up there. They're all 2x6s too. And sometimes the ridges could possibly be 2x8s. Mainly on the framing is what I wanted to show you, is why you get cracks over your headers or by your doors. And there's a couple different reasons. This is a normal 2x10 header. This is why all the over your windows, your doors are all like this. When you decide to do some remodeling in 20 years from now, this board here is going to shrink tremendously, and all the lumber that comes out now is very wet. And in 20 years, 10 years, I bet this thing will shrink a 1/4 inch at least, maybe 3/8, but it will shrink quite a bit. So sometimes you get cracks that come off the edge of the door, and it's mainly probably because things are shrinking. It isn't that your house is falling apart, so everything kind of shrinks. They're making these lumber now, they call them LVLs, and these do not shrink. And got a great big one here, and this header here is holding up this whole, that's why we don't have no walls underneath this, and we can make it open. Put these LVLs in. There's 3 of those, and they're all bolted together, and they won't shrink. Now, certain floor plans call for these LVLs to be in your floor, and the problem with that is your 2x10s. This is what the normal 2x10 is right here. This 2x10 is going to shrink. This LVL is not going to shrink. So if you have the LVLs in your floor, you need to make sure that the roofing crew builds this as close to perfect as they can, because this one isn't going to shrink, this one's going to shrink, and it's kind of a nightmare, and we try to stay away from it the most we can. You can use some trusses for the floor system, which is better than that, because when it shrinks and everything moves, your whole house moves. It's full of water right now, and that's a problem. And when it shrinks, things move. You got nail pops, you've got things of that nature, and it's kind of the way it is. I build these walls here where there's an interior wall meets an exterior we don't extend this stud back. We've got it so there's insulation behind there. And used to build them to where this met this, if this 2x4 wall met this 2x4 wall, you can't get no insulation there. So this is kind of an insulation thing, which we'll go over on the next frame. Mainly on the framing, you know, everybody builds everything real close to the same. The most important parts of the framing is here. Here's just a normal wall, and above the wall you see these 2x4s going up. That is resting all the roof down on this wall. Well, sometimes the framers don't put a double joist or a joist at all underneath the floor here. This is your floor system, and we need to have a joist underneath this thing. In this case, there is one. It's transferring all the weight all the way down, and kind of when the builder walks through this thing, he needs to make sure that the roughing crew built it the way the guy drew it up, because he drew it with 2x10s and stuff underneath there, and if they're transferring that weight down, I want to make sure that that's done correctly. Really, on the framing, I think it's all pretty standard. We'll go to the next one. We can continue our framing going to the basement. And if you remember, in a few other frames, I pointed out that the house could move up and down. This is a basement wall here, and you see we have a gap between the floor. This is your floor, and this is the basement wall. And if you remember, I said that your concrete floor could heave up, and that was one reason why we just concreted these today. We had a hole here, and our posts sit in the hole. And now if your concrete floor heaves up, the house is not going to move up, because this post here is on the pier pad. It's not sitting on the floor, and that's a big difference. Now, so if your floor would heave up, your first floor will not move doing it this way. A lot of builders set the post on the concrete floor. So if your concrete floor heaves up, your first floor moves up. We just saw the crack, you know, half-inch crack we have at the top of the floor, and that's where the basement wall meets the ceiling. We have a crack there. All the basement walls are built with a crack, so if the floor heaves up, it can move without raising the first floor. And this is something that a lot of the builders do not do, and I pointed that out on my, I believe, the concrete video. I showed you the rings, and that we didn't pour them full of concrete, and that is why. So what we try to do is minimize any movement on the first floor, and it's, you know, your house could move, your house couldn't move, nobody knows, but you know, this just try to help things out a little bit more, and keep things nice. So we do put we put some air up there, so if the floor does move up, and it won't transfer to the first floor.